Thanks, Tony. Yeah, let me share my screen. Hope that everybody can hear me correctly. I'm going to share. This is the slides. Okay, sure. And there we go. We've got 20 minutes just to show Istio. So no much slides, a lot of code. And yeah, I know that it's only 20 minutes, but we'll see if we can cover as much topic as possible. The first thing that you need to know is that everything that I'm talking here and much more can be replayed by you at home. And this is the link I'm going to share you in the chat. If chat is somewhere here. Where is chat? Here, chat. Okay, here is the link. So feel free to just follow the examples or just rerun the examples after that at home without any kind of problem. And as we said, I'm Alex Soto. I work in Red Hat. I'm Red Hat's director of developer experience. I'm author of Testing Java Microservices and also the author of Carcass Cookbook. And of course, if you want to stay updated about topics like Java, Kubernetes and Java, Kafka, Istio, Knative, all this kind of cloud topics, then just follow me on Twitter, and I will be able to you'll be able to stay updated all the time. Also, if you subscribe to Red Hat Developers, which is developers.redhat.com, you can download for free the Istio Service Mesh book and the migrating to microservices database, just for free. Just register, and then for free you can download it, and you can also learn about all these topics that I'm going to show you today. So to get started, just these 2 minutes of talking about me. Now it's time to talk about Istio. Then I've shared with you an application. This application is open, it's public, and you can get it from you can click it on home, and you will get it a similar screen like you can see now, and see that it's iterating every second from canary, which is yellow, to blue. Okay, and then it changes to green, right? So it's iterating from time to time. Why it's happening this? Well, actually, this is I have here my you can see here. Keep kind of notes. I've got here my Kubernetes cluster. In this case, I've got the cluster in Amazon, and my data center is in Frankfurt, and I'm using, I think that it's like 3 masters and 6 worker nodes, right? This is my Kubernetes cluster. In fact, it's an OpenShift, right? But at the end, OpenShift is Kubernetes. So if I do kubectl get pods, you can see that I've got 2 pods of canary, 2 pods of blue, and 2 pods of green. And basically what I'm doing, my front end is just sending a request, and this request goes to the blue pod, then it sends another request and goes to the canary pod, and then it sends the next request goes to green. So for this reason, you can see that it's iterating over and over and over and again. But what's happening if I want to send all my traffic to the blue, so everyone can just get it a blue background? Then I can just do kubectl apply -f. These files are at source main Istio virtual service blue. I just apply this resource. In fact, this resource is an Istio resource. And now notice that all the time the background is in blue, and probably the same at your home. Now I'm going to show you how to do that, of course, because probably some of you are saying how this YAML file looks like, right? But let me, for example, apply another file. In this case, I'm going to source main Istio virtual service, for example, green, and apply this resource. And well, it's, it takes a bit of time. And now, in a few moments, few seconds, now it's green. And all the time it's going to be green. And this is happening because I'm changing the routines. So the first routing was a round-robin approach, which is just iterating from all the pods. And then when I said to Istio, now just use blue, it always goes to blue. When I say green, just always go to green. If you want to see how these files look like, because probably you want to see how this magic works, I can show you here for example, the green, and see that the only thing that I'm doing, the important things of all this file is this root section, which I'm saying that I want to send all the requests to the green version. Notice that I'm seeing weight 100. It means that 100% of the traffic goes to green. You can think that, of course, it's exactly the same thing when I want to go, for example, to for example, blue. Go to blue, it's exactly the same. And the root version is saying, send all the traffic to the version blue. No redeployments. I'm not redeploying anything. Always it's the same pods, but I'm just changing the root rules. Yeah, you want to see more advanced use case or interesting use cases? How about changing, depending on the browser, if the output is green or the output is yellow? And it just depends on the browser. So I'm going to just do kubectl apply. Dev source main Istio virtual service, for example, Firefox. Okay, now notice what's going to happen. This is a Chrome and it's green. And it's going to be green all the time. But now I'm going to open my Firefox, which is here, and I'm going to copy this URL. Notice that it's exactly the same URL. I'm not changing anything. And yellow. So depending on the browser, I'm sending the traffic to one pod or another pod. In this case, if it's a Chrome, it goes to the green pod. If it's Firefox, it goes to the yellow pod. So how this works, again, it's not so hard. You just need to do source main Istio virtual service Firefox and see the important thing is again in the root. And I'm saying if the header user agent is Firefox, then send all the traffic to Canary, which is the yellow one. And if not, by default, what is the default? Sorry, wait, the default is over here. And if not, by default, send it to the green. Notice here I'm sending all the traffic by default to the green. And in case of having a header with header name user agent and with the value something that contains Firefox, then it's sending to the Canary. So it's really easy to rebalance all your traffic depending on external parameters. And again, notice that if I do kubectl get pods, kubectl get pods, you can see that the pods has not been redeployed at any time. It's like 9 hours. I started these pods this morning and they are still there. And without redeploying anything, I'm just changing the route, the traffic, right? Then let me show you the last slides. How it works? Well, it works in something like that. We've got Istio, and before Istio, usually what we have is like our service. If this service is written in Java, it's running inside the JVM, and then we've got a container, right? And then this container is deployed inside a pod. You can think of a pod like a machine that it's running things. But inside these services, we are using some microservice capabilities like discovery, load balancer, resiliency, metrics, and tracing, right? Most of you, if you are using Java, probably you're using Istrix or Resilience for J for resiliency, or for example, embedding the Jigger client or Zipkin client inside your service to do distributed tracing, or or exposing the slash metrics, right, to grab information from Prometheus. And then again, we've got the service V and also the service T. And that's fine, but notice that you are repeating over and over again all this stuff. So what it's doing Istio is taking all this information in putting inside a sidecar, right? And a sidecar, it's simple, another container that is running inside the pod. And what's really happening here is that Istio container is intercepting all the network traffic. So now when you want to do a request from service A to service V, what you are really doing is connecting service A to the sidecar container. This sidecar container makes the request to the other sidecar container. This sidecar container then do the request to service B, And when it gets a response, this response is sent back to the sidecar container, and the sidecar container sends a request to the other sidecar container and then to the service A. So you can see that there is never a direct connection between A and B, but there is all the traffic is intercepted and done with this sidecar container. And how we can see this, that it's really like this. Notice that when I've done the kubectl get pods, you see that here it says ready to. Notice that this pod contains two containers, two running containers. One, which is my service, the blue service, and another one that is the Istio proxy. In fact, if I do a kubectl describe pod and I put it this, kubectl describe pod, you can see over here that there is two containers. One is the Istio proxy, right? And the other one, which is over here, is the blue-green canary service. So as you can see, there is one pod with two containers. One is my service, and the other one is the proxy that intercepts all the network. So let's do some more things. We've seen that we can redirect the traffic blindly. So all to blue, all to green, all to canary, or we can also redirect the traffic depending on a hidden value. But let's see more examples. Let me change to another namespace. This is the tutorial namespace. I'm using Kubernetes, which is a tool for changing Kubernetes namespaces in an easy way, because it's not I need to remember all this kubectl config set context blah blah blah, which is really long. Okay, that's fine, but I use Kubernetes. And then let me go through the Istio tutorial where I have more and more YAML files. And in this case, I got another example, and this example is 3 services. I can do kubectl get pods so you can see it. And you can see that I've got customer preference, and then I've got recommendation B1 and recommendation B2. So I've got two recommendation services running, right? And customer calls preference and preference calls recommendation. Then when I've done here the curl, you can see that I'm just running customer to preference to recommendation B1. And if I do another curl now, I'm going to B1, another call, I'm going to B2, and now I'm going to B1, and I'm going to B2, okay? So basically this is happening because by default, it's a round robin approach. So I'm just going first to B1, then to B2, first to B1, then to B2. Now, can I make this run better? Yes, I can just send the traffic as we've seen to all to B1. And to do that, I just need to go to Istio files and first of all, register my services with this destination rule. I mean that destination rules are used for a lot of things, but for now, you can think like destination rule is a way to register and to instruct Istio that there are 2 services of type recommendation B1, recommendation B2. And then I can do a kubectl apply -f Istio files. And again, I can just use a virtual service and send all the traffic to B1, which sometimes takes a bit of time, but depends on the cluster. Now it's working, and I can, for example, let's do a call again, and notice that all the time it's going to B1. Okay. Now, as you can think that this file is exactly the same as the blue-green that I've showed you before, but now I'm saying that in the root, I want to send all the traffic to recommendation V1. But let's, for example, do another thing. How about doing a canary release, right? Sending traffic, a portion of traffic, not all the traffic to one or to all the traffic to another one, but just sending portions of traffic. For example, 75% of the traffic to version V1 and 25% of the traffic to service V2. Then it's really easy. Notice that I'm not redeploying anything. I also think that this is really hard to do with plain Kubernetes, and this is exactly why Istio is here, to help you do all these advanced deployment techniques. I'm going to do virtual service, for example, sending 75% to the traffic to V1, 25 to V2, and then I apply it. Do while. And now I think that it might work in this way. Notice that most of the time it's getting B1s and sometimes I'm getting a B2. The reason for this is that because I'm sending 75% of the traffic to B1, 25 to B2. So I'm effectively doing a canary release. And if you want to see this file, probably most of you already figured out how this file will look like, but just in case, notice that I'm here, I'm just setting two new rules. One rule that says send 75% to the traffic to be1, and another rule which says send 25% of the traffic to be2. This is how Istio works. Then let me show you another thing. Let's probably I will not have much time, but let me show you one interesting example about resiliency, how Istio helps you and make your application more resilient. Let me send again all the traffic to, well, I can just, get back to round robin approach. To get back, just need to do a delete, because at the end, this is just a Kubernetes resource, so I can delete this resource. Basically, I'm going to delete this one. And now, again, I'm just having this round robin B2, B1, B2, B1, okay? Again, then, remember, I've got customer that calls recommendation, customer that calls preference, and preference calls recommendation B1 and recommendation B2. Now, what's happened if V2 starts failing? Let's simulate that. I'm going to go inside this spot, okay? See what. It's called recommendation now. Wait. See recommendation /bin/bash. So now I'm entering inside this container that is running recommendation. Notice that it takes a bit of time, but when this command finish, now I'm just inside the recommendation container. Notice that I can do curl localhost 8080, and you can curl localhost, and I'm getting recommendation B2 right all the time, because at the end I'm just doing a localhost call because I'm inside the container. And now I've got a special endpoint which is called misbehave, and now makes that always this call will return an error. In fact, if I do this, you'll see that this call is always returning a 503. So I'm making this recommendation B2 unstable or just failing because maybe it's really busy and it cannot serve any other requests, or maybe because there is some kind of bugs. Okay, now the question is, what's happening if I do a call? Probably you will say, if I'm going to be one, it's going to work pretty well. But if I'm going to be two, then 502, right? Okay, let's try it. I do a call, I'm going to be one. I do a call, I'm going to be one. I do a call, I'm going to be one. I do a call, I'm going to be one. Why is this happening? This is happening because by default, Istio implements automatic retries. So what's happening is that the first time when it needs to go to B1, then it goes to B1 and returns back to response. But when it goes to B2, the B2 returns an error. And then, since Istio has an automatic retry, it says, okay, V2 has failed. Let me do another retry and see if it works or not. And the retry, since it's in a round robin approach, it goes to B1. And then it returns the response from B1. So notice that thanks of Istio, you can you have automatic resiliency, just doing nothing. Just install Istio and boom, you've got these automatic retries. Of course, you've got a lot of more things that we can cover in 20 minutes. For example, circuit breakers, MTLS, security with egress, I don't know, a lot of stuff. But hope that this just encourage you to follow the link that I've showed you for the tutorial, or just by yourself start using Istio. Just the last thing, because we are almost run out of time, just the last minute, is that with Istio, it's not only comes with all these, proxy, but it comes also with an ecosystem of tools that helps you to observe your microservice architecture. It comes with Prometheus and Grafana. So you just install Istio and you've got Prometheus and Grafana for all your traffic. And also it comes with Kiali. Kiali is this project that allows you to visualize your application. I can go here, for example, tutorial and say, hey, look, my tutorial, it comes with customer preference recommendation. If I go to a graph, and in the tutorial, I can see that customer calls preference and preference calls recommendation B1 and B2. And if I'm going here and I do traffic animation and I'm gonna start sending traffic, let me put 10 minutes here, and I'm gonna start sending traffic all the time. Well, I can do this, oops. While now you can see here how the traffic is behaving all the time, right? It's going from customer preference recommendation V1 or V2, and then it goes to the jigger to distributed tracing. And notice that now V2 it's painted as red because this service it's failing. So you can just see here and say, oh, look, it seems that V2 it's behaving incorrectly, but the errors are never sent back to the colors because are green. And pretty much that's all. Thank you very much for coming to this session, and I hope you enjoyed this meetup. And now I'm going to start answering all your questions. Thank you and bye-bye.
It's great. Thanks, Alex. I'm sure you're getting a round of applause from everyone at home. You've got a couple of questions on there. So Adil Ahmed with the first one, how would you compare Istio against HashiCorp console?
Yeah, it's a service mesh, right? I mean that it's Istio. Yeah, and there are more service meshes, not only the HashiCorp console and Istio. There is, for example, Istio uses Envoy, but also, for example, there is Linkerd. So it's another approach to use service mesh. Well, I would say that Istio was created for running in Kubernetes, and console, I mean, probably it's more running for, let's say, another systems, right? I'm not saying that you cannot run console on Kubernetes, because probably you can do it, but this is the measure, maybe difference. Of course, I'm not an expert of console, so I cannot give you a really valid comparison in the sense, but Istio, it's coming from Google and IBM and Red Hat and so on, and it's using the, it's like, okay, we know Kubernetes, let's do Istio, so we know how Kubernetes works, and we can create, let's say, a really nice integration with Kubernetes and Istio. Yeah, as I said, I'm not saying that console it's not working with Kubernetes. I'm just saying that Istio was created for Kubernetes, and so it might work better, but that's all. I cannot give you a really more concrete answer to this question.
Sure. Good question from James Downing. At what level of scale do you think a service mesh is needed?
If a service mesh is needed, well, at the end, it depends on what you are doing. If you're doing a microservices architecture, then probably yes. And the answer, and the reason is that if you're doing a microservice architecture, probably you still need tracing your requests. If not, okay, you can do microservices without tracing, but it can be a nightmare. Probably you are still using Prometheus and Grafana if you're just using microservice architecture, and this comes with Istio. And probably if you're doing a true microservice architecture, and when I say true microservice architecture, I mean 50 microservices, 100 microservices, I mean big microservices, then probably you're still using circuit breakers, or you want to do canary releases, or blue-green deployments, or mirroring traffic on all this kind of stuff, right? Probably you want to do that. And if you are deploying to Kubernetes, you will, I mean that with just a naked Kubernetes, let's say, you see that it's really hard to do this kind of advanced deployments, or putting a lot of code inside your services, right? Like secret breakers, or for doing discovery patterns inside the code. So with Istio, if you are just using microservices architecture, then yes, use it, because at the end you've got this code. At the end you have this code in another part. In this way, you've got all the code in a single place. But if you're just having like 5 microservices or 6 services, then maybe it's not required. But yeah, at the end it depends a lot of the use case that you want to cover.
We've already got time for one more quick question. Probably leads quite nicely into this one from Agnes Garu. I found that Istio metrics are a little painful to get working. Lots of different tech is needed, Prometheus, sidecars, etc. Are there any easy off-the-shelf configs?
Yeah, I mean that in this case, when you install, when you want to install Istio, you can choose different profiles. In this case, I'm always using the full profile, so it's everything there. But you can choose another profiles, which is like, okay, I don't want to use metrics, I don't want to use Prometheus, I don't want to use Grafana, I don't want to use Jigger. Just I want to use the Istio with the proxy for resiliency stuff. Then that's fine. I mean, nobody needs to implement or install the full solution for Istio. But also, yeah, about it's true that some people say about or complains about the performance. Okay, but at the end, it's not a problem in the performance of Istio. It's as I said, if you are using a microservice architecture and you're, for example, using Jigger for tracing your requests, you're spending this time as well there. So if you want to use Jigger, it doesn't matter if you're using in your application or in Istio, because at the end, the performance is going to be similar.
Brilliant. Thanks a lot, Alex. There's a couple more questions on the Q&A as well that you can possibly duck into and
sure.
now. Yeah, thanks a lot for joining us. That was really great. And we will now pass on to Marcia for a talk on migrating existing applications to serverless.
Thank you.
Hello. I hope you can all hear me. I will share my screen. And let's get started. I, in general, been doing this presentation in slots of 1 hour. So I hope you're seeing my screen. It's working. So I have made it shorter, way shorter, but I'm happy to answer any questions then offline. So we are going to talk today about how to migrate an existing applications to serverless. I will talk a little bit about some of the examples are more about monolith and also microservices. So it's a mix of both. First, I want to introduce myself. My name is Marcia. I'm a developer advocate for AWS. I've been in the company for 8 months. And before that, I've been doing serverless as a developer for, I don't know, since 2016. So since quite early from the serverless wave. I'm the host of a YouTube channel. As they mentioned at the beginning, I have over 250 videos on serverless where you can learn all kinds of things. So if you are interested in getting your hands on this, go and check it. So let's get started. So the presentation will be split in basically 2 parts. First, a not that successful story on migration, and then a successful story on migration. The non-successful story is my personal story. And the other one is one of the AWS customers that did a really great job. But first, just that everybody gets with the same picture of what is serverless, I want to go through what it means to have a serverless architecture, to have a serverless components, or to have serverless whatever you like to call it. I call it a methodology. And the idea is to maximize the value without doing, basically rewriting the wheel, making the wheel again. So these are 2 comments from 2 different serverless influencers, Jeremy Daly and Jared Short, and I think they explain very well what serverless is. Basically, if the platform has it, use it, get it from the market, try to think about how you can reutilize as much as possible and focus on what really provides the core value for your stakeholders. So something is serverless when it agrees with these 4 kind of characteristics. It scales automatically. Basically, You don't need to be on call or anything. If it goes viral at Korea in 3 in the morning, you can be sleeping and you don't care. You pay for how much you use. Well, the scaling automatically, there are always soft limits and edge cases, but it's not as you need to be paying attention a lot to them. Well, you need to know them, but you don't need to be like, after you know them, then everything should be fine. You pay for how much you use. It's like electricity. You have a bill at the end of the month on how much you have been using. You don't need to manage any infrastructure whatsoever. You don't need to care about what version of the operating system Lambda is running or S3 is running or anything like that. You are super abstracted from your infrastructure. And then it comes with high availability built in. And that's something, for example, if you're using virtual machines in the cloud, you might need to deploy it with one availability zone and have that managed. But when you're working with serverless, you're deploying inside the region and you will get the benefit of having your systems available into multiple availability zones. So basically, building serverless applications is like putting Legos together. You have all these components, computing components, you have, I don't know, storage component, networking components, APIs, queues, messaging, and you need to build them together into something that looks like this, that it's maybe a little bit, I like this example because it's a very busy picture and I don't think it's a good example to display an architecture like this, but it's a real architecture of a social media that the Burning Monk, one of the serverless heroes, have created in the past. And I think it's a good representation. If you put everything in the same picture, it just looks like little Lego blocks connected to each other that do small little things and make the whole system work. So let's start with the first story. That is my story, my first serverless project ever. It was 2016, early 2016. And I was working in this company where we're making like a Netflix for cartoons. It was a very successful project. It has been out for 5 years already. And we have around 6 billion views. So it was very, very successful. You know, kids like to replay and replay the videos a million times. And the thing with this service is that it was free. We were monetizing by ads. So when you're doing a service that is streaming video on the internet and getting money from ads, then you need to be very conscious on your spending and on your architecture. This application was created by a small group of developers, including me, and we were all very cloud naive. We didn't know much about cloud economics. We just built Java applications that were microservices that ended being small monoliths because we were too lazy or too busy. I don't know how you like to call it. And because it was also hard to deploy new microservices. And it ended up being quite expensive to run in the cloud. So we got a message from stakeholders that says that our project will get canceled if we don't do anything about it. The first thing we did was try to optimize the code. As we knew, as developers, we tried to add caches and add all kind of things, but nothing helped. So it was summer and I was doing some pet projects. Serverless was cool. It was starting out and I was playing with it. And at the same time, we were rethinking the architecture because we realized that we needed to do an architecture change in our application. And we realized that we needed to do a massive architecture change. So I told my boss, and my boss, maybe he was too good, I don't know. I told my boss, hey, let's go with the serverless road. And he said, sure, why not? Nobody knew how to deploy more than 4 Lambdas. That was all my experience in serverless. So this was a bumpy road. We were 3 developers taking the lead on this, and we decided to go through a not really good path. That was the big rewrite. And I think this is not a good migration strategy for anybody. We have a project, it was not a big project. I think we calculated and we were quite good in the planning. We calculated it will take 6 months to rewrite all, and it took around 8 months to rewrite it all. And we decided to go to production one day in the future. It was bad, very bad. Very, very bad. First, because, well, you know, the requirements, the application keep on growing as time passed because new features were added and we needed to add the new features and we needed them to migrate them. And that was a bad idea already. Then everybody was like super pending on our migration. We had a lot of pressure. We were working on all kind of parts of the system, and we were taking decisions at the beginning of the project, like our CI/CD pipelines, monitoring, and all kind of things that then were basically we were testing them for the first time with real production information on 7-8 months down the path. So it was a very, very painful experience. We managed to migrate it. It took many weeks. I don't know how long it took. It seems like years. It was not years. It was many weeks of lots of work, lots of crunching, and lots of learning. And also this, I think, applies to any new technology, because by that time there was not much documentation on serverless, not much experience on how to migrate, not much experience on how to manage production services on serverless. So it was very, very painful. So I don't recommend this strategy whatsoever. The strategy that I would recommend is the one from our second story, that is the story of Comic Relief. Comic Relief is a British company that, well, they're an NGO. They're not a company. They take over the television. Maybe the guys watching this from UK know this company. They take over the television for one day. They invite actors, musicians, comedians, and they get money, they get donations, and then they donate them to some good cause. So it's one day basically at the year where they are getting lots of money and lots of donations from many people. And before they did the migration to serverless, they were able to accept donations once a year because they need to set up such a very complex system, and they could not afford it doing it after this time. So they have one big challenge on this service, that it was that they have 350 donations per second. Maybe you think it's not that big number, but it is, because donations is not something that you can do duplicates. You cannot retry, you cannot lost. They're very critical information that needs to be handled very careful. If you lost one donation, people might not come back and donate. If you do 2 times a donation, that's not a good idea. So each donation is very, 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 very important. And this is a very critical part of the whole system. And if they fail here, they also will lose the trust of the audience that are watching, and the audience might not want to donate. So by 2016, they started their kind of thinking of migrating. They started more or less at the same time that we did. And this was the architecture they have. They have one big monolith for Drupal, for their content, static content and things like that. Then they have one page for giving pages, and we are not focusing in there. And then they have another monolith or microservice that was too big, that is for the donate. And this is the part that is the critical part of the system, the one that they wanted to migrate out and to make more flexible and easier to handle and more resilient. So here they started asking the question, where we need to start migrating from. Sometimes we think about the strategy 1, that is to start migrating from the least critical part of our system, start migrating something that is not relevant, that nobody cares, so we can make mistakes and try things. But then when is the point that we need to move to this migrating the critical part of our system, the one that will get us the most return on our invested time? Sometimes we want to start with the second strategy, and that's not good. We don't want to do that. We want to do a mixture of trying with the first strategy, migrate as many small things as we can, test our decisions, our CI, our monitoring, and our infrastructure as code, that the team learns, that they feel comfortable, and then we move to the most critical part. So that's what this team in Comic Relief did. They started by migrating something super small thing that it was an image gallery with some pictures that they were not really a critical component. Nobody really watched them that much. And they migrated to serverless and to newer technologies like React and took it out from the Drupal monolith. And they started to feel comfortable that this is something that is the right path. In 2018, they migrated out some other small services that maybe they were a little bit more critical, like the contact us form, but still quite simple. And they also started creating a whole framework to reutilize components around their different services. In 2019 is where they did the big bang of migrations and when they migrate the Donate platform. And here is when the whole thing changed. Now they can accept donations all year round, and their whole architecture now from the perspective of the critical part is serverless and using modern technologies. So if you want to take a look at the architecture, it's available in this URL. You can take a picture and take a look at it later. But basically the architecture is extremely resilient. So all the different donations are coming into service, into the system, and they have multiple layers of failover. If there's any problem, somebody's going to take care of those donations. So nothing is get lost, nothing comes duplicate, and there is no problem with it. And this is one of the most interesting graphs, I think, that they had is the cost. So before starting their process of migration in 2015, they have $84,000 of cost per year in all their computing and storage and whatever IT things that they have with their Drupal and all the stuff. In 2019, after the migration was done, it was $5,400 a year, and from which only 92 was about this Donate service. The rest was basically their Drupal monolith that they have for their static content and for other things. And they have everything as infrastructure as code. They can replicate it as many times, they can test it, they can grow it, they can change it. And the most important thing is that they can accept donations all the time. So if you want to donate, you can do that. So basically their strategy was a simple strategy, a Strangler pattern strategy. And this applies to monolith as well as to services that we want to get out. So it's taking pieces of code and migrating in a graceful way. And also if you have a monolith, you need to manage the API and the database. So let's look at 5 simple steps to migrate to serverless. And usually this part takes me like half an hour, and I'll try to do it in like 10 minutes. So the first thing that you need to do is to think your foundational work. And this is something that is very important. And your foundational work is basically deciding on what is the microservices that you want to have, how your system should communicate to each other. You can decide on the size of the microservices that you're going to have. I like to work with this 2-week rewrite size. So you make microservices that are big as that you can rewrite them in 2 weeks, because you want to have an architecture that can evolve and can change, and it's kind of easy to throw to the trash and start again if something changed. Then you need to pick your developer tools, your frameworks, your programming languages, your, I don't know, whatever you need. And sometimes when you're working with serverless, you might need to pick different tools for different problems. So for example, and I think this applies to any technology, for serverless, you might want to use, if you're working with Lambda functions, you might want to use serverless framework or AWS SAM. If you're working with more static AWS infrastructure, you might use CloudFormation or CDK. If you're working with the front end and GraphQL, you might want to use Amplify. So depending on which type of microservice, you might want to pick different type of tools. And this applies as well for the infrastructure as code. This is something you need to have from day 0. Before starting anything, all your developers need to be trained on how to use infrastructure as code. In serverless projects, developers are building infrastructure, and that's something very important to have in mind. It's not only your ops teams that will be building infrastructure, but developers will be building functions, messaging queues and event reach and things like that. So they need to know how to write infrastructure as code. One very important thing is that you have a CI/CD pipeline and you decide how things are going to be deployed, what kind of stages and what kind of type of deployment you will have. Are you going to do canaries? Are you going to do safe deployments? Whatever, how your tests are going to run, everything needs to be defined. You want to test this and iterate over it, as when you're doing the steps in your Strangler pattern, you're migrating things and testing your foundational work all the time and improving it. So when you get to migrate your critical part, all this foundational work is extremely oiled. And very important, monitoring and observability. When we started our migration process, the failure story, we didn't thought about monitoring and observability first, because by that time there was no serverless observability tools. Second, we didn't know that monitoring serverless applications is very different than monitoring traditional applications. So that's something you need to master, because debugging serverless applications is very hard. You need to be able to trace your requests through multiple different services and resources and asynchronous calls. So you need to have that in place from day zero. It's way harder to do later on. So after you have done your foundational work, you need to start, if you have a monolith, you might need to migrate it to the cloud if it's not, and then you need to start finding those kind of bounded domains of where you will have your new microservices coming out. And then you will organize your code inside your monolith, and also you will start breaking your data dependencies. So you will need to break the database in the next steps. So you want to start creating these little silos inside your monolith, if that's the case. Then you will start moving your code gracefully to serverless. And in order to move to serverless, there are many different things that you need to go do. But I will try to give you at least the most important tips. These are the express tips to design serverless application. The first one is think about logical microservices. You don't want to get your mind that a Lambda function is a microservices. No, a Lambda function is not a microservice. Your whole application is not a microservice. You need to think about microservices as something that you can rewrite in an X amount of time, something that is small. I like to say 2 weeks. I think it's Saul Newman that said that, and I really like that since I heard it. Then you want all your Lambdas and all the resources to, if possible, be inside one GitHub repo, for example, inside one SAM template, AWS SAM template, or in one CloudFormation template. So you can deploy this whole microservice in one go. And you want these microservices to be independently deployed from each other, but maybe the internal components might have dependencies on each other. And this will make your application way easier to handle. You want inside your microservices, your Lambda functions to connect through queues or for something else. And I will talk about that in a second, not directly. And you want your database to be private to that logical microservice. So any other Lambda function or computing or whatever cannot access your database. It only can be accessed from within your logical microservice. The second thing you need to have in mind, and things you need to refactor your application to, is to adhere to the concept of event-driven architectures. This is something that is super important to have in place when you are working with serverless. And if you start thinking about event-driven architectures, you're starting to get as many of the benefits of having a serverless architecture. For doing that, you need to decouple your services and your functions. You don't have functions talking to functions. That add coupling and that adds complexity. And that makes all your things very, basically at the end of the day, you might be writing a big monolith. So you want to have queues or PubSub, or even better, I like to put between my logical microservices an event bus. This will make everything more scalable, more independent, more modular. So then you can replace one microservice with another one new and nothing will get affected. And this event bus between your microservices is very important. Is a way that all your basically microservices can talk to each other and communicate. And if we look at traditional applications before the cloud, you think, oh, event buses are kind of a single point of failure, but that's not the case anymore when you're working with serverless technologies in the cloud. There is event bridge, is the same idea of an event bus with all the benefits of a managed service. And that's my third tip. Replace whatever you can with managed services. Don't manage it yourself. Don't do managed queues. Use managed queues. Don't have a system to manage queues. Don't do authentication yourself unless it's something that is really giving value. Try not to do it yourself. Try to replace it with something that is either in the cloud provider that you choose or in some third parties. There's multiple things that you can choose. For example, you want a NoSQL database. Well, you can go with Dynamo if you're inside AWS and you like it, but then it's Mongo Atlas as well. And there is many others that you can choose. So there is plenty of options and you don't need to have the pain of managing a database that is distributed in multiple nodes and how to scale it and how to manage the keys and how to back it up. It's not your problem, and your customers don't care unless you're a database provider. But if you're providing something else, why to bother? So then we move our code to serverless and we refactor it. It's not lift and shift. If you lift and shift, you are not earning any benefits. Just staying wherever you are and migrate to containers if you want to lift and shift. If you want to go to serverless, you really need to break the concepts that you know from traditional application and move to distributed systems and to event-driven architecture. The next step is to break the database. If you have a monolith, you might need to break the database. And even if you have a traditional microservice with an SQL database, you might want to rethink your database now. Sometimes SQL is not the most scalable databases. You might want to migrate it to an NoSQL if possible, or even to files. There's multiple ways that you can do interesting things with files nowadays, and in a file system like S3, you can even perform SQL queries if that's the case. So try to think what is the best way to store your critical data. And finally, we want to talk about breaking the APIs. And I think the previous talk is a good example on how you can do migrations of your customers with, I don't know, 25% of your traffic. Try it a little bit, make sure that it works, and then move the rest. And play a little bit with that. If you're in AWS, you can use canary deployments, linear deployments. You can use also the application load balancer. It has weighted targets, so you can say send 10% of the traffic to my new target. So there's multiple things that you can do in order to be able to move to this new API without affecting your clients. That's something very important. You don't want to go and change the client to this new migration. You want to keep it everything seamless for your clients, but then you might want to try it. I will be, if I will go back to 2016 when we were doing this migration, and there were no tools like this by then, but if they will be, I will be so grateful, because we were migrating basically 100% of our traffic from one day and then realizing that it did not work. And we were pushing back and moving forward. There was nothing that we could decide now, 10% comes here and test it with a small scale, and let's not affect all the customers. So I think this is something super important to take a look when you're going to a migration. And that's it. Steps: do your foundational work, move your monolith to the cloud, find the bounded context for your code, organize your data layer in your monolith, start breaking out the monolith, refactor to serverless with good strategies, use event-driven architectures, replace as much as you can with managed services, break the database, move it to something that is more scalable and more distributed, and that can take care better of the load and the growth of your application. Break the APIs without destroying your clients, and be able to move the traffic in a graceful way to your new API. And then repeat from 5 to 7 until you're done migrating all the services you want to serverless. And that's it. And I think I did it in less than 20 minutes, I hope.
Yeah, just about. No, that's great. Brilliant. Thanks very much. And yeah, a link to Marcy's YouTube channel is also in the comments. If you want to go on there and click and subscribe, feel free to do so. So yeah, really, really interesting. Thanks very much for that. Yeah, great case study on comic relief. The amount of money this saves is unbelievable. So we've got a couple of questions. So one from Ravi Kumar Siravaj. So what rules do I split a monolith to a group of lambdas? So is it by class or modules, key methods, functionality, etc.?
Well, as I said, you're not lifting and shifting. You will need to do a lot of work to migrate that piece of functionality into a Lambda function. So you should start looking at what is the problem that that piece of software that you want to migrate. It can be a class, or it can be a set of classes, or it can be, I don't know, sometimes when you have a monolith, everything is if it's a good organized monolith, you might have packages, for example, in Java, you might have all your application organized in different packages. So then you can say, well, I will start migrating this package. And then you need to start rethinking with these at least 3 principles that I show you. And there's way more if I will have longer time, but thinking about how you can make it event-driven, how you can decouple all these services, and then how you can take advantage of managed services. So for example, if you have a reporting system, you might just drop all the code whatsoever and go through a whole serverless analytic pipeline using, I don't know, AWS components, just put in an example. So there are some things that you will migrate when it's your business logic. You might need to put that code inside a Lambda function because that's very proprietary for you. But when you are looking at a whole application, there is so much code that is really not providing any value, and it's just moving things from one place to another and doing things that can be done with a managed service. So it goes case by case.
Okay, great. And another one from George Pinto. So what are your thoughts about serverless framework and its own CI/CD solution?
I think the important thing is that you do an analysis on what is the best infrastructure as code tool for you and what is the best CI/CD solution for you. I don't have any thoughts because I cannot tell you what is the best tool. Every project is different, and for example, serverless framework has a lot of great things like the plugin support, it's open source, and it's multi-cloud. So if you want to go through the multi-cloud idea, then you might want to go into serverless framework. If you want to take advantage of a third-party provider for the CI/CD, you can go through serverless framework. I think the important thing is to do an analysis and to be confident that that's the best solution for your particular use case.
And final question from Smith Claudia, is functional domain modeling and FP a better match for serverless?
FP? Functional programming, maybe?
Functional programming, I assume, yeah.
So that's something internal to the Lambda functions. I always try to go to functional programming when doing code in general because it's way cleaner and you have less state and side effects. But serverless is not only about Lambdas. Lambdas are just a bit of a serverless architecture. When you start going through making your own serverless architectures, you will notice that you can do a lot of things without putting any code at all. So if you can do functional programming, I will totally recommend it for life, for everything that you can do, just because it's so clean and nice and easy to read. So I don't know, it's good for everything.
Sure, okay, great. Well, thanks a lot there, Marcia. There's a couple of other questions, one from Andy Hamilton and a couple of others
yes,
on there.
I can answer a little bit.
Yeah, if you can answer those, that'd be great. And yeah, next up is Paul from Google giving us an overview on Capitan. Let's take it away, Paul. Cheers.
Hello. Let me just share my screen. Okay, so this should be visible. Right. So thank you for joining me. I'm going to be presenting Capitan. It's a tool for generic configuration management for various other front ends for deploying or managing resources in the cloud. I'm going to give a short historical intro, a quick overview, a deep dive in the features, and then some future plans. The slides are more text heavy than that I'm going to be describing. They're meant to be looked at after the actual talk for references. So a very quick intro. Capitan was developed in-house at DeepMind Health, which has now moved to Google. It was open sourced in October 2017. You can basically write your templates for your various components in 4 languages or input types at the moment. So JSONet is a very popular one, Jinja 2. Helm charts can be imported, and then their values can be overlaid with other specific values. And then Python, which gives you the full flexibility of the language to template any resource you want. Capitan then generates YAML, JSON, or text files from these templates, which can be used in other applications. We took part in the Google Summer of Code in 2019 last year and this year as well, in an effort to improve some of our features and make sure we keep building on what we have. So Capitan is suitable for anything that consumes JSON, YAML, or TXT for its configuration. Kubernetes is obviously a big example. Terraform also accepts JSON, Spinnaker, Prometheus, Alert Manager, possibly Ansible. I haven't tried it, but it should be doable. They all consume JSON, YAML, or text. So you can probably use Capitan to template these tools. Also, Capitan does a lot more. It also generates playbooks, so documentation, scripts, and anything else that could be text-based. You have a feature called a hierarchical inventory, which is accessible by all of your templates. This inventory holds information specific to each target you're generating and is used for deduplicating basically information across multiple targets. Also, Capitan generates secrets automatically for you with various backends. Right now, these backends include GPG, GCP's key management system, and AWS key management system. Essentially, it creates a key in all of these backends and then encrypts your secrets and stores them locally in your source code encrypted. And then you decrypt them upon deployment. I'll get into more detail later. So let's have a quick overview. But before that, what are the principles? Why do we need another templating tool? The concept at the time when templating tools for Kubernetes or Terraform weren't that available was have everything for your infrastructure checked in version control. So everything including Kubernetes, Terraform, all sorts of other technologies you use to deploy something and have it run on the cloud or in a data center. You want to abstract the operations on these resources as much as possible. So you don't want your DevOps or whoever's operating these cloud infrastructures to have to remember various command line arguments or how do they log in to specific environments to do something. You want to script all of that in a nice templated way that is replicatable in different environments with different infrastructure details, like different networks, for example, different cluster setups. So all of that can be abstracted through Capitan and then outputted to automated scripts for deployment. Capitan is also great at embedding business concepts in your infrastructure as code. I'll get into that a bit later. And then the actual stage of deploying changes to your infrastructure is out of scope. So each of these tools has a different method to apply the changes from source code to the actual infrastructure. Kubernetes has its own kubectl or anything else you might use for deployments like cap or other things. Terraform has the Terraform binary, but because all of these deployment operations are tool specific, it's out of Capitan's scope on how you deploy it. And that gives it a lot of flexibility, of course. And so a quick overview of how Capitan works, sort of. So we have the inventory. The inventory is basically a lot of YAML classes. These YAML classes are inherited by targets. Targets are equally YAML classes. Capitan parses through each of these target YAMLs and essentially inherits all of these classes and their properties. Properties meaning keys and values that describe your infrastructure. For example, a number of deployments could be written in class A. Class B could extend that number of deployments to, for example, 10 replicas or something like that. Then target A inherits this from this class, and then the new value is this number 10 for the replicas. So this is what builds your source of truth, source of values for your infrastructure. Then you have basically your inputs. So these are your templates. These are written in Jinja, JSONet, or Python, or Helm. And then you essentially write whatever component you want here. So this could be deployments, anything Kubernetes related. It could be resources for Terraform, databases, and other stuff that you want to generate, like documentation or scripts. Capitan takes both of these, compiles the inventory values into the templated files, and then generates the output for each target individually. The output per target could look something like this. So you could have your Terraform output, your manifest for Kubernetes, your documentation, and your scripts in various folders. At the same time, Capitan also encrypts your secrets. So it takes the secret definition from classes in your inventory. It talks to whatever backend you use for that secret, so GPG, GKMS, or AWS KMS, and then it encrypts the secret and stores it into the output files wherever it's used. And so upon deployment, when you deploy and run the actual script, you do Capitan reveal, it reveals the secret to whoever is deploying this. So it assumes you have the correct permissions to deploy and read the secret. And then it applies your change to whatever infrastructure you want. This actually helps a lot because by separating secrets per target, you can have use cases where developers have permission to deploy whatever change or secret they want in dev environments, but then prod environments are more locked, and you don't give developers permission to decrypt these secrets, even though they're in the same folder. So you can sort of join your two deployment strategies for different types of environments in one place, and then that place behaves correctly per environment and maintains this privilege separation. A bit zoom in into this. So you have your data, which comes from the inventory. These are some examples of targets. So you can have some dev targets, Minikube, prod. Your secrets as well are generated by Capitan. You combine those in the templates, and it compiles to something like this. So this is an example of a target Minikube, where you have a bunch of manifests. This one is yellow because essentially it highlights that there is a secret value encrypted in this YAML file that has to be revealed before applying. You also apply you also generate your scripts for applying, for if you're setting up your cluster, setting up your context. So basically, no developer has to know how to switch contexts or clusters in Kubernetes. You just wrap all of that in some scripts and you abstract it for them, and you just tell them, run this script if you want to interact with this dev cluster. So some deep dive in what these targets and inventory actually is, or how it looks like. The inventory is meant to be the single source of truth for your deployments, for anything you generate. An inventory example could be like this, sorry, a target example. It inherits some classes, some common attributes, some specific attributes for Minikube, some releases which are related to your dev app, and then some other components, for example, that you want to deploy in this specific Minikube cluster. You might want to deploy a web server and a Postgres proxy as well. So all of these classes are basically other YAML files in the same repository, which have their own properties that define each of these elements. So dev releases, for example, could have your Docker tag for your applications and the release tag, right? So if you want to move an environment to a newer release, all you have to do is inherit a new class which points to the correct Docker tag, for example. This is a nice abstraction because it gives developers the huge flexibility of changing infrastructure arguments or environment variables without depending on the SRE or DevOps teams when they need to actually do these changes. They can go inside the repository, change their dev target to inherit whatever release they want. They can deploy it because they have the permissions to do so. And when they're sure that this is the change they want to apply, they just send a merge request to the repository with your infrastructure and keep it in code for permanent. Yeah, and one last comment is that the order of inheritance here matters. So essentially, whatever attributes you inherit from common, you can override them in the other classes that follow up, which gives you great flexibility because you can do certain configurations for dev targets, and then you can overwrite it in very specific components if you want different behaviors, for example. And so you're not tied to a specific configuration just because you inherit a class. So what are these classes actually? They're, again, YAML. Essentially, this is how it looks like. Everything is prefixed with the root key parameters, and that's how you reference everything in the templates as well. And then you use whatever keywords you want here to define your infrastructure. So you can set up, instance names, you can change images when you deploy them in certain places, you can build services with different types, and you can also inherit entire subtrees of this inventory in other places. So when you actually use this, and this is reclass, by the way, internally, it inherits all of this block, whether it's a dictionary or an array or a list, it will basically go under this tree and expand, which gives you great flexibility as a pattern to define some default values you want applied everywhere in all of your targets, all of your components. For example, replica number 1, that's your default. Then you want to override that if you create different components and you want them to have more replicas, for example. Oops. So using Capitan to simplify env access, as I mentioned before, you can basically template your setup cluster scripts as an example, very simple one. So this is how it would look like. You have your source, your inventory essentially here. This is defining some cluster related attributes, right? Your zone, your name, what the type is, anything else that you wanna use basically in this. Then this is your template for your bash script. So you can see this is Jinja 2. You initialize with hashbang, you create your inventory. So this is inventory.parameters. This is the same parameters that is here, right? After inheriting all of your classes in your target. And so here, essentially, you write whatever you would write in normal bash. And whenever you want to use an item from the inventory, like the target name, for example, or the cluster name, you reference it like this in Jinja. Basically Jinja, like simple, but extended with this inventory concept, which gives you very strong reusability across multiple components. And this is how the output would look like. So you see the cluster name is replaced, the user is replaced, namespace as well. And essentially all of these are variables you can modify in different targets like dev, prod, staging, or anything else you want, and change them to whatever value you want. This is an example of documentation as well. Again, Jinja, but the inventory parameters are still here. And you can see that the final output replaces essentially all of these values. Your release type, everything else is now reflected in live documentation. So every time you compile a new target and you want to present some information to people that aren't necessarily technical about that target, you can just generate some readmes and then point people to those readmes and tell them, here's everything you need to know about this environment, which services it has, what clusters it has, what IPs it exposes publicly, for example. All of these things can be encapsulated with your infrastructure at the same place and auto-generated. Capitan also generates secrets. So the benefit of this is that there's usually a heavy toll on DevOps or SRE teams that they have to manage secrets for different environments. And if the process is manual, it can really block continuous secret management, or it can make key rotation, for example, much harder. So why not generate these secrets at the same place where you generate and template your other components? It simplifies things a lot. So this is how you would define, for example, in your inventory, again, what key would you use for these secrets? So you can see for GPG, you can use the key of this example developer to encrypt secrets. Otherwise, in GKMS, you can use this fake key to encrypt every secret, or in AWS, use this key. And so how do you actually create a key or a secret? Sorry. You can use the manual command in Capitan. So Capitan refs is basically references. It's an abstraction over secrets, but it's the same thing in this scope. You can write the secret to this path by using the GKMS backend based on this target's configuration, and then you input the secret file, your origin of the secret. But if you want to automatically generate secrets because you don't care what the values are, as long as they're secure and large enough with good enough entropy, you can just put in your inventory something like this key, which generates a GPG secret for a specific target, saves it in this path, and the secret, if it doesn't exist, that's what this OR operator does, it will be generated as a random string and base 64'd. So essentially it generates your secrets and then you can modify them in the format that you want to consume them in. So base 64 is a common example for Kubernetes secrets, which have to be base 64'd, and you can do that in the same place you generate them with one simple step. And then how do you actually create and use this secret? So you've defined your secret here, you've defined your key, and then compiled output from Capitan will contain this. So you notice that this is basically the same, but there's a hash here. This hash is a hash of your secret contents. And then the purpose is that if you update secrets, you want to have this visible in your Git or SVN or whatever version control system. So this hash, when you parse this entire file through Capitan reveal, which is a different command, it will decrypt this magic string and replace it with the actual value of the secret, which you can do upon deployment, on that deployment step. So an expansion maybe on the business concepts. So given we have these tools, the inventory, the classes, the templates, and the secret management, how can we organize our infrastructure in a way where maximum reusability is achieved for the values as well as the template code? Because you don't want to write the same deployment code over and over or copy paste it 1,000 times. And then if you ever need to change anything, you have to change it in 1,000 files. So app releases sort of can now be classes. What this means is that every application you deploy in your infrastructure probably has some command line arguments, some images, Docker images, or maybe files mounted, volume mounts. All of this can now be expressed as a class, and then you inherit it to specific targets you want. Essentially, you can express all of these app-specific features as a class, which you inherit on your cycle of release. So dev targets would inherit it first, then UAT or whatever else you have in your environment, staging, and then production. And all you essentially change in these targets is you inherit a different class each time. And therefore you change these attributes like app flags. This helps you very easily to create multiple identical environments to test business logic. So there's a new feature, you want to test it, but you don't want to deploy it anywhere unsafe. You can deploy it in dev targets, for example, first. Capitan will compile that and show you what the difference is when you change a new release. And then you can compare that with the changes you expect, make sure those are correct, and then deploy it in all of the other stages. Now, besides that, you can abstract more concepts into classes. So your dev targets or staging or prod, all of these environments have some common concepts. For example, user access or production environments could be more hardened in various ways, networking-wise. Maybe they don't have custom networks to allow for developers to do some things. So all of these specifics can be grouped into classes, and then you have an assurance in code that all of these environments that are dev have the same behavior and same configuration and setup. And so if you see a different problem or you have to debug something and you're not sure what's wrong, you can compare two environments and use Capitan to basically tell the differences between those two environments and easily triage your debugging process. Also, you can put data center specific or cloud provider specific information inside these classes. So if you deploy the same microservices in AWS or GCP or a custom data center, you can change whatever specifics those places have, but the rest you can just reuse across all targets. So maybe the network is different in all of these resources, or some credentials or some users are different. You can encapsulate that in a class and then inherit it only to targets that run on AWS, for example, or GCP or whatever else. This is an image that sort of demonstrates this concept better. So you have these underlined boxes are essentially your targets, your leads in this Capitan inventory. You can have multiple dev targets, for example. All of these dev targets could inherit a release 1.1, which is basically release 1.0 plus a new feature. This new feature changes some config or a flag or whatever else. This is a class, a YAML class. It also had an old feature, feature A, which is also currently deployed in production, right? So your dev targets now inherit the old functionality, exactly the same as it is in production, plus some new functionality or configs, which is what you want to extend on. At the same time, You can have generic classes that are inherited by all of your targets, like security features. Something needs to be hardened in some virtual machine or some Kubernetes configuration, and so you want to make sure you inherit that in every single target everywhere, and you're not forgetting to update one specific environment. So just inherit that class everywhere, and that's it. You're done. You probably don't even need to copy-paste this into multiple places because it's hierarchical. If you inherit this class high enough on the list, for example, in common, you can make sure that it's inherited in all of your targets. And so when I mentioned business logic here, I basically meant that when your developers want to test a new release, they can easily test it on dev, and then all they have to do, for example, for the staging environment, is change one class name to release 1.1 instead of 1.0, and that will be inherited in all of the staging environments. Then you just deploy that. People, testers, creating an actual test, make sure that this infrastructure works as you would expect again, and then you can actually advance it to different releases and environments. The padlocks here are meant to demonstrate a secret. So in this config or class, there is a secret, same as here. I use a different color, green and red, because essentially when you automatically create secrets by Capitan, it creates different secrets per target. So even though my secret's name for dev environments is the same, the value of the secret in production is different, which means that if a secret leaks from a dev environment, it won't be the same as the prod one, and therefore, you're not in immediate danger, although you should rotate it. So what does this mean, essentially? It gives you much bigger flexibility when you have to deploy to a lot of different environments, but at the same time, you don't want to write the same configuration over and over just to switch a couple of the parameters inside and make sure that works in your environment. It simplifies secret management, obviously, and at the same time, you have greater reusability of templated code, but the benefit as well, which I didn't mention here, is in debugging. So if you see a problem in staging or development, for example, it's much easier to debug larger microservices when you can compare the same microservice working in a different environment, and you have a great deal of certainty that all the other surrounding components around the microservice are identical. So it helps you a lot in eliminating commonalities between environments, and therefore finding something that is different and might break something. Also, because everything is now in code and is also versioned, your code is your source of truth, and you can run a lot of tests on it. You can run tests on your infrastructure to make sure, for example, that your JSON template doesn't generate VMs in the region that is not supported by AWS, for example, because you can add that in code and have a list of supported regions which you want to assert on, essentially. So it simplifies testing your infrastructure a lot. Other capabilities, which I didn't create a whole slide for, but they're built in, is you can validate your Kubernetes output against the official schemas. So that was a project from last year's Summer of Code. Essentially, it downloads the official schemas from a Kubernetes repository and then validates your compiled manifests against those schemas to make sure you're not making mistakes in your deployments or stateful sets or whatever else. You can import existing Helm charts and overlay inventory values on top of them. This was useful for simplifying the migration to Capitan for a lot of people. Secrets can accept subvariables. So up until now, secrets were just strings, essentially. So you encrypt them, you save them encrypted in the compiled output, but that's it. Then when you reveal them, it's basically a string. Now there's new functionality with subvariables. So essentially you can encrypt an entire YAML file, and all of it will be encrypted in source code. And when you reveal it, you can decrypt essentially specific values from that YAML file only, without decrypting the entire YAML file. So this simplifies management of like complicated secrets or larger structures of secrets significantly. We have alpha support for Vault key value. We want to extend that to the full spectrum of Vault. That would help a lot in secret integrations. We have a feature for external dependencies. Essentially, if you have multiple repositories with your components or your templates, or you have public repositories like the one we have as a reference, you can fetch them remotely with HTTPS or Git and use them in your repository the same way that you would use Git modules, for example. And one of the nicest, very new features is the embedded secrets in the compiled output. So up until now, when you encrypt a secret, it's stored in the refs folder, so refs /. Therefore, when you reveal that secret, you need that folder. It's a dependency, which doesn't work well if your deployments are done by Jenkins or some other job runner in an automated way without humans. So this new feature allows developers to store these secrets inside the actual output. So in my manifest-secret.yaml, and it's the entire secret is contained inside the same YAML. So you can reveal it without any dependencies on different files, which helps a lot if you want to do headless deployments, basically, in any CI/CD you're using. Some future plans as a last note. We want to improve the support for Vault. We want to add capabilities for remote inventory fetching. Essentially, if you have lots of inventories or classes which describe very complex information, and you want to split that to multiple repositories, for example, or reuse someone else's inventory, we want to be able to do that. We would like to improve packaging for Capitan, the binary, and the OSX support. It works right now, but the library that is used for Helm, I think, for the dependency is not so easy to be packaged inside, so we want to work on that. We want to switch from standard JSONet to Go JSONet, which in some preliminary tests is more than 5 times faster when compiling, so that's a great bonus. We want to create a secrets controller for Kubernetes. This controller would essentially take your manifests and then reveal the secrets for you without the need for a human to have permissions to reveal them. This would allow even developers to push to production, in quotes, because that's not a great strategy, without needing extra permissions, but with the assurance that all of this will work. And ideally, new input languages. It's flexible, so it could be extended to more languages. Contributions are welcome. Questions, and then 2 notes is check capitan.dev for documentation and examples, or #Capitan on the Slack of Kubernetes.
That's great. Thanks very much, Paul. It's really, really interesting. A couple of quick questions. So first one from our good friend Renaud Gurin. So how does Capitan compare to Customize, and when would you use one over the other?
So I'm not super familiar with Customize. That's my bad. Sorry. I'm not sure. I am not aware of Customize having the ability of an inventory or secret management. So just the templating part exists in a lot of tools, but the combination of the inventory, which is your social truth for everything, is sort of unique from what I've seen, unless I'm making a mistake, in which case I'm sorry.
No worries. And another question, sorry, from Renaud as well, is Capitan used to only support JSONnet for templates. Is Ginger 2 now a class citizen, or are there limitations?
No, it's fully operational. We use it every day. And I would also strongly suggest people try the Cadet, which is the Python input language. It gives you the full flexibility of Python to template anything you want, to customize your inventory values in any way you want, and then generate a unique template. And because it's Python, I believe you can also modify the extension you output. I might be wrong on that. Ask on the Slack channel for more information.
Okay, great. One more question. How does Capitan work alongside traditional configuration management tools like Puppet or Chef? or will it replace those tools?
So the concept is not to replace, more or less. It's to deduplicate and have a common set of values, your inventory, in one place instead of 15. So Capitan essentially would probably generate your chef configurations or your Puppet configurations, and then you would still use those tools to apply them to whatever environment you want. It's the same way that you would do it with Kubernetes or Terraform, essentially. You want your other tools to handle the deployment part and also validate that the changes you've done, the configs you've done are correct, but you want something to abstract those configs. I'll give you a quick example. So say you're creating a lot of Terraform infrastructure. You're creating a Kubernetes cluster, you're creating a database, and a network, obviously, and some other stuff. When you create these things, essentially what you get back is in your inventory some ranges, for example. For example, you can define specific ranges for your network and therefore your Kubernetes cluster. Those ranges will exist in your inventory. When I say ranges, I mean IP ranges. Then you can reuse those ranges in your firewall configuration, the same ranges exactly, without even having to remember them or copy paste them, to set up your firewall rules based on the cluster you've actually created. After that, you can also configure these things in specific resources. So if your application needs to know about the database IP, you don't have to copy paste it from the Kubernetes manifest to the Terraform manifest. You just reuse it from the same inventory. So that gives you a lot of power and way less code.
That's great. Thanks, Paul. And obviously, any more questions, just jump onto the Capitan Slack channel, speak to the community on there, and I'm sure they can answer. So, yeah, brilliant. Just to kind of round up then, thanks very much to Alex, to Marcia, and to Paul for their talks. Really, really, really appreciate it. Some really good talks this evening. We've got 2 events coming up in June, so June the 4th and June the 18th, I believe, or 19th. If you're interested in doing a talk, if you've got something interesting that the community might like to hear about, feel free to get in touch with us. And yeah, we'll see you next time. Thanks very much. Enjoy your evening.